says write down the equations. Write down the equations of the asymptotes of f. Right? So 4.1, the equations of the asymptotes, there are two. There is a vertical asymptote which starts with x. There is a horizontal asymptote which starts with y. Now, this equation here is not written as the general equation, but we can simplify it and write it as f of x equal to 2 over x plus 3 plus 1. Okay, so it's just changing the position of the 1 and the fraction. That's all. Sorry, I said you need to pay attention. Right, so the vertical asymptote, the equation will be x equal to. Now, remember what I told you that with regard to the vertical asymptote, right, x plus 3 is going to be equal to x plus p. Therefore, p is going to be 3. But the general equation is x equal to minus p, which means our equation is going to be equal to x equal to minus 3. That's the equation of the vertical asymptote, to be x equal to negative 3. The horizontal asymptote is going to be equal to y equal to 1. Okay? It's going to be y equal to 1. Right? Right? It's going to be y equal to 1. Now, the horizontal asymptote is very easy because it's given by this value here. That's straightforward. But to get the, or rather to write down the equation of the vertical asymptote, you have to be very careful. Determine P first, okay, using the calculation that I showed you there. So this calculation here, it helps you to determine the correct value of P. And you need to be aware that the equation of the asymptote is x equal to minus P. Then you substitute it there, and then you are done. So that's 4.1. This is a very common question up to metric. Writing down the equations of the asymptotes of a hyperbola, it's a very important concept. Yes?
If P is negative, so for example, if it's negative,
Yeah, then it means the equation becomes x equal to positive 3. Right. Like 4.2, calculate the x and y intercepts. Now, the x and y intercepts, obviously, if I want to calculate my x-intercept, by now we should know that I have to substitute, in this case, f of x equal to 0. Okay? So, my equation is f of x equal to 2 over x plus 3 plus 1. Right? Okay? So, if I want to find the x-intercept, means I have to substitute f of x to 0, so I'll put 0 there, equal to 2 over x plus 3 plus 1. Now, when you get to this point here, please, you should not get scared as to what to do next. You must take this constant here to the left-hand side. Okay? Don't do anything else. Take the constant to the left-hand side. Then it becomes negative 1. And this will be equal to 2 over x plus 3. Okay? Then be aware that the denominator of that minus 1 is a 1. Therefore, cross multiply. So 1 multiplies the 2. This negative 1 multiplies both the x and the positive 3. So you get minus x minus 3 equal to positive 2. If you simplify this, you get minus x equal to positive 5. Since the coefficient of x here is negative, it means that the answer for x is going to be negative 5. Right? So if you did the question, you mark your way. Right? Then The y-intercept, we have to substitute. Now be aware that here the question does not say the coordinates of the x and y intercepts. So we're only finding the value of x at the value of x at the intercept and the value of y at the intercept. Okay? Then we substitute here x equal to 0, right? Because we are calculating the y-intercept. So where there is x there, so it will be f0. F0 means the value of y when x is 0. That's what f0 means. Value of y when x is 0. So this will be 2 divided by 0 plus 3 plus 1. And then you get 2 over 3 plus 1. If you simplify that, that's very simple. It will give you 5 over 3. Okay? So that will be got 5 over 3. Alright, yes? No, the final answer must be 5 over 3. So, this one here. Yeah, but remember, here, can you please be part of the lesson? You don't have to say anything, just be part of the lesson. Alright, so we are trying to calculate the y-intercept, which means it's a value, one value. So this one here, eventually it has to disappear until you get to what? 5 over 3. We have to simplify until you get to one value.
So, yes? You're talking about, you know that the original equation it was 1 plus 2 over x plus 3. She's saying is it wrong if you went for 1 where it originally was, if you didn't swap the 2 around? Because in the beginning you swapped the 2 around, you said 2 over x plus 3 plus 1.
Okay, thank you. Because maybe the way she said that I didn't understand it. So were you referring to not swapping the two? Yeah, it's fine. As long as you can be able to identify your P and the Q value, it's okay. But you can also find your X and your X and Y intercept when it's like this. It's fine. Okay. The reason why I converted it to that was because it's easier to work with it in its general form as compared to when it's like this. Right? Okay, so this is what we got. Now, be aware that where I put f of 0 is equal to 5 over 3, we can also write that as y equal to 5 over 3. But you can leave it like this. It's to the y-intercept. Okay, because that's in function notation, which you are supposed to be familiar with. Yes?
So what if you just add it further?
To write it as 1 and 2 over 3.
No, one decimal.
No, there is no need to convert it to a decimal. Generally, this topic on functions, I don't encourage you to work with decimals. Only integers and fractions. Okay? Because if you convert it to 1,677, it's exactly the same as 5 over 3. So there's no point. Okay. Alright. You see, when you are sketching, okay, maybe for sketching purposes, in your case, if you want to make it easier for yourself, you can write that after that y got 5 over 3 when you are sketching. Alright, so the next question now, we have to sketch. Okay? Draw a neat sketch of f, clearly indicating all intercepts with the axis and any asymptotes. So we need to indicate the intercepts, we need to also draw our asymptotes. So I'm going to do that now. So these two are our equations of asymptotes. I found x-intercepts, x equal to -5 and x equal to 5. So y equal to 5 over 3. So I need a blank page where I will draw the graph. So I've got -5, therefore I'll put it like, draw it like that. Then if I put 1 here, then I can put 2 there, maybe -1 there, minus 2. Then I can have minus 1, minus 2, minus 3, minus 4, minus 5. Then I can have negative 6 there. Then 1, 2, and then 3. Right, so first thing, you draw the horizontal asymptote and the vertical asymptote first. So our horizontal asymptote is y equal to 1. Therefore, I can draw my horizontal asymptote. Right? Okay, so that's y equal to 1. Okay, let me use a different color to write the equation. So this is y equal to 1. Then my vertical asymptote it's at x equal to negative 3. Right? So I might need, okay, I'll extend it going that way. Let's try it. Okay, I will extend it. Okay, then okay, wait, you see what I'm trying to do there. Alright, so I'll put the 3 there, so the negative 3, that's where the x-intercept is. Okay, wait. X is negative 3. Okay, I see what you mean. Alright, let me recalibrate. Let me change my scale here. So I'll change it. Okay, let me change it. Okay, so I can put minus 1 there, minus 2, minus 3, minus 4, minus 5, maybe minus 6 there. Then 1, 2, 3, 4, 5. Right? So at x equal to negative 3, we have got a vertical asymptote, so let me draw it. Right? Then, once you have finished drawing the asymptotes, the next thing is plot the points where the x and y intercepts are. So we have an x-intercept at y equal to, sorry, at x equal to negative 5. So I've got an x-intercept there, right? And I also have an x-intercept at y equal to 5 over 3. Now, 5 over 3 is 1,7 somewhere, 1,67, which is close to 1,7. So I'm just going to approximate it as to be somewhere there. Okay? Remember, this is a sketch. Okay? Now, because the numerator, this value here, it's a positive. Okay? It means that the curves are going to be in the first quadrant and the third quadrant. Yes?
Would you get multi-dotted if you were to try and find another point for that curve, like you equate x to a number on another point?
Well, that's not necessary.
So the time that you do that,
There are no maps allocated for that. There are no maps allocated. Remember, I told that normally it's 3 or 4 maps. Look here, how many maps it's allocated? 4. Right? So don't try to do anything else which you are not asked to do. Alright, so we are in the third quadrant, so it means when I sketch it, it will be like that. Right? And then to be in the first quadrant, so to go like that. Okay. So that's the graph. Okay? That's the graph. Right. Then let's just add some information on it before the lesson ends. Right? I'm not going to start anything new now. I'll start the exponential on Monday. All right. The domain. The domain here is going to be x is an element of real numbers, but x is not equal to what? Negative 5. And the range, it will be y is an element of real numbers, but y is not equal to what? It will be equal to 1.
And isn't the first one?
It's positive 1. Okay, this is not, this is supposed to be, it's supposed to be negative 3.
Oh, yes.
Please, you must put the answer here. Here. Let me just indicate in the color. The value here and there, it has to be the value at the horizontal and vertical asymptote. That is the coordinates of this point, not the x and y intercepts. Please. Right? Then there is a fourth question. Don't worry, I'm aware of that there is another question. All right. The next question is on transformation. Right? Right. The next question is on transformation. Is there anybody who has got a question? Is there anyone who has got any question? Right. Now, for this question, we didn't, there was no question asked about the line of symmetry, right? But it's part of the next question now, which is this one. Number 4.4. 4.4 says, given that H is a reflection of F in the x-axis, right? Determine the equation of F of axis of symmetry of H having a positive gradient. Right, now for you to be able to do this question, you have to know the equation of H first after the reflection. You have to know the equation. Now, there's a reflection rule for reflection about the x-axis, okay, which I will tell you now, and I'll also give you the one for reflection about the y-axis. In fact, I think, let me talk a little bit in more detail about reflection on Monday, but you did part of that in grade 10. Right, so I'm going to do that question, 4.4. So 4.4, the equation f of x is equal to 2 over x plus 3 plus 1. Do you know that if you reflect a point about the x-axis, the x value doesn't change, but the y values changes in terms of its sign. So the y values changes from being positive to negative or negative to positive. Now, in function notation, the rule is this one here, or the equation for h of x, it will be h of x will be equal to minus f of x. This is the general equation for reflection about the x-axis. Okay, for today, I'll tell you the one for the x-axis, then Monday I'll tell you for y-axis. Okay, so what you have to do is just substitute the right-hand side of f of x. Whatever resulting equation you get, that's the equation for h of x. So for our question means h of x will be equal to minus, open bracket, 2 over x plus 3 plus 1. And this becomes minus 2 over x plus 3 minus 1. So this will be the equation for h of x. Okay? So this is the equation for h of x. I'm sure you can see that I did not guess the equation. Okay? Then, from here now, I need to determine now my line of symmetry with a positive gradient. Remember, The equation of that line of symmetry is y equal to x plus p plus q. Okay?
Sir.
No.
X plus 3 is 1.
No, because remember, x plus 3 is a denominator, 2 is a numerator. So this is a fraction. So if you multiply negative 1 by the fraction, the whole fraction changes from being positive to negative. And for the hyperbola, the denominator is always positive. But the numerator is the one which becomes what? Negative. Alright, are you following that? Now, I already calculated P. P is equal to positive 3. Okay? So this, well, do you know what happens when it comes to reflection here? If you are reflecting about the x-axis, right? The x values don't change. They remain what? The same. Which means the vertical asymptote does not what? Does not change. But the horizontal asymptote what? Changes. Do you understand that? The vertical asymptote doesn't change.
It goes from 1 to negative 1 basically.
Yes, but the horizontal asymptote is the one which changes.
Yeah, so that's why it goes from 1 to negative 1.
Yes. So P here is still positive 3, but Q is now what? Minus 1. Are you following? So the equation with the positive gradient is y equal to x plus what? Plus 2. Are you following? Reflection about the x-axis does not affect the x values. So the vertical asymptote is not affected. It's only the horizontal asymptote which changes. So this asymptote, this one here, okay, after reflection, the vertical asymptote still remains the same, but the horizontal asymptote becomes y equal to negative 1. Right?